You know, you would think after 2 fails I would learn my lesson, but not here. No such thing will be done. I will keep going. So, third time's the charm. This is yet another 900 series NVIDIA card. It is a GTX 980 this time. And it is the Phantom from Gainward. This uses the same PCB as the Palette Jetstream, because Gainward is a sub-brand of Palette. They use the same PCBs. The only difference is the cooler, and I think the display out config, because I think the Palette card has a more normal config than whatever this is. But yeah, so I got this thing for 20 euros, which is much more acceptable than the 60 I had to pay for the TI. And yeah, you can already see what's wrong with this. So there's 2 missing diarmoses right here. I can actually tell you that there's another dead one on here as well. I did get 2 new FDMF 6823Cs from the seller actually, which is nice, but because there's at least a third dead one here, I guess I'm gonna have to get out the 770 Jetstream that's dead and steal another diarmos off of that card. But yeah, so this is basically the exact same vCore VRM as on the 980 Ti G1 Gaming, but on a 980 non-Ti. So for this core, the GM204, this VRM is very, very strong. Like on a GM200, the VRM is adequate to slightly concerning. On a GM204, this is very strong, because this is also the same VRM they had on the 780 Jetstream and Phantom, and on that card it was also adequate and very slightly concerning, but on this, like, it'll be fine. But so yeah, so to the state of the card, you can see, well, already mentioned, 2 missing diarmoses, 2 missing fuses, because on Palette and Game 1 cards, all inputs are usually fused, so this fuse, I'm assuming, is still okay. Let's check that. Is this fuse still okay? It is. And, you know, let's just do the usual troubleshooting steps. So let's measure all the 12-volt inputs. PCIe is okay. I'm assuming that is PCIe, or actually the 6-pin, I don't really know. Let's just check all the shunt resistors. Check both. Well, they're fine. The inputs are fine. Then for resistance, let's actually do that on the back, because we have through-hole inductors. Let's check the memory resistance. You can't really see it. 15.8 ohms, that's a bit low, but we have Samsung modules on this card, and if I remember correctly, those usually have a rather low resistance. And it's not like 100 milliohms, so that still looks fine. And then the core, that's a bit low for a 28 nanometer core, which indicates a problem on the core, which is why I said that there's already a dead diarmos on this thing, because we have missing fuses. So we've established that this fuse is okay and the input is okay, so we have no short circuit here. Let's take this missing fuse that's connected to the 2 missing diarmoses, and you can see we also don't have a short circuit on that. Let's take this missing fuse that's connected to probably the lower 4 phases here, and as you see, there's a short circuit right there. And I'm pretty sure I know exactly which diarmos is faulty, because this one's spewing solder balls. So this one is probably dead. It makes me actually question if these 2 were okay and the person just like started removing diarmoses, got bored after the second one, and then gave up on the card. Like, I assume this thing also, well, no, like if the fuse is missing, I guess this also blew. So I suppose all the, like, there's actually multiple short circuits in this VRM, which is slightly concerning because that doesn't usually happen, but I have a lot of FDMF 6823Cs on dead cards, so I can just replace all of them if I want to. And worst case, I slap an e-power onto this thing. So I thought this time I was actually gonna do my stuff on camera, so I have my hot plate right here, and I'm going to remove this suspicious looking diarmos, And if my suspicion is correct, after this is gone, we will have no more short circuit. And we should actually be able to, well, we have to bridge the where the fuses go. Because I don't have any replacement fuses, I'm just going to have to bridge this with a cable for now. But I will remove this. We will probably see that the short circuit is gone. I will bridge these fuse pads, and then we should be able to boot the card. I'm not going to run a load on this because we would be missing 3 phases at that point, but the card should run. So yeah, let's get my hot air station and remove the dead DRMOS. So, the DRMOS is removed, and if I may demonstrate, we now put a multimeter in continuity mode and measure the formerly shorted side. There's no more short, and in resistance mode, we also no longer have 200 milliohms. So, short circuit is fixed. One other thing that I should mention is on this card. You know, the FDMF6823C is not the most powerful DRMOS ever made. It's a 50 amp part, it's a rather old 50 amp part, and these fail somewhat often. Not because they're bad parts, usually the cards that they fail on are just underpowered in how many of them they have. But one other thing that I have seen on this PCB, or pretty much all the derivatives of this PCB, so that includes like the 780 as well, like pretty much everything from Palette and GameWorld that uses this 8-phase of FDMF6823Cs, is sometimes these input capacitors, these multilayer ceramics, sometimes these also go short circuit and cause a short on 12 volts. It doesn't always have to be a DRMOS that dies. In this case, we did have solder blobs that indicated which one it was. But sometimes these input multilayer ceramics also go short. I think I remember someone having a 960 Phantom that had that, and they just needed to pull one of the multilayer ceramics, and because you have so many of them, you probably don't even need to replace it. And that's just what it is. In fact, I did have a very similar thing on a GTX 680 Windforce from Gigabyte, where I had a multilayer ceramic capacitor go short circuit on the input side of the memory VRM, which actually blew the PCI Express fuse on that card, and therefore it didn't work anymore. So I identified that capacitor, removed it, replaced the fuse, and then the card worked again. But in this case, we did have a dead DRMOS. And let's demonstrate that it's actually dead. Let's take this pad. It's actually not shorted to that one. It is shorted to the high side though. So as far as I know, the big layer is the switch node, and this one should be the high side pad, and it very much is failed closed. So it would always be sending 12 volts to the output, which destroys our GPU core and of course blows the fuses on this card, which is why it's always nice to have fuses on your card. Palette and GameWorld are doing a very good job at having so many fuses on their PCBs, though they are doing it at the cost of not having input inductors, which, they had enough space to include both. But honestly, I would just get like a good power, honestly, I think having input fuses is more important than input inductors, because if your power supply is good enough, it's gonna be able to deal with the switching noise from the card. It's just, would be cool to have both. Anyway, since this is now gone, the shorted out DRMOS is gone, I'm now going to bridge these two pads, so we actually have 12 volt power going to the V-Core VRM again. And then I will try to boot up the card to check if it installs the drivers and maybe runs the GPU-Z render test. I'm not going to put any proper actual stress test load on this, because at this point we are down to 5 of the 8 phases, which might actually be enough to run the card, but I'm not going to risk it. So I've put these red wires onto where the fuses would usually go, as you can see. So this will enable the card to again send 12 volt power to the vCore VRM, so we can test if the card still works. Because when a VRM dies, especially when a high side MOSFET fails closed, there will be excess voltage going to whatever the VRM is powering, and there's always a slight chance that this kills the core or like the memory. If the memory VRM dies, it can kill both the memory and the memory controller in the core. I've never seen a core actually die from a dead vCore VRM, but I've seen cores die from dead memory VRMs as well as memory chips. But before I put any effort into putting extra power stages on this, I just want to make sure the card works. I just want to see it put out an image, I want to see it install the driver, because for that even 5 phases of the VRM should be enough. Also, you should never do this if you plan to actually run the card like this. The fuses exist for a reason, and although these cables are pretty thin and would probably burn out in the case of a short circuit, that's not guaranteed. Fuses are guaranteed to burn out at a certain current level. So if you were going to make this repair on a professional level, you should put new fuses on here. I just don't have replacement parts right now. And since the card is just for my own use as an overclocking card, and I know that the power supply I will be using this card with has a very good overcurrent protection, I am okay with running the card like this, but you should not be. If you repair a card in a professional manner, you should put proper fuses here. So just keep that in mind. But yeah, so the next part is like putting a small heatsink onto the core so it can idle in Windows, and just seeing if it installs the driver and runs the GPU render test. So, I tried booting the card, but it does actually not work. And I think I know why. So, NVIDIA cards usually have at least one phase of every VRM wired to the PCI Express slot for power, because when you forget to plug these in, the card will be able to display the error message saying, please plug in the PCI Express power cables. It would not be able to do that if one of the VRMs would not receive power from the PCI Express slot. And for the vCore VRM, this phase up here is wired to the PCI Express slot. I think that this phase is required to run for the card to boot up, because as far as I know, like, the card doesn't always run all phases for efficiency reasons. And in the lowest phase count, as far as I know, usually only the phases of the PCI Express slot do run, which would be this phase up here, which can't run because the DRMOS is missing. This phase is on the 8 pin and this is on the 6 pin, so those are probably not completely needed, but at least this one is. So I've decided to solder the DRMOSs on, at least the 2 I have. The third one I will need to salvage one from a dead card and then also solder on. So I've decided to just go ahead and do that. So I will clean up the pads a little bit and then solder on the new DRMOSs. So I have soldered on the 2 new DRMOSs. I originally wanted to put the second one here, but then I noticed that there's 2 little resistors next to the DRMOS, where one I accidentally desoldered and the second one is missing. And without those, I don't think the phase can work. So I've decided to put the other DRMOS here, where the resistors are still in place. Now this missing resistor might actually be why the card wasn't powering up first, but we now have what should be working phase connected to the PCI Express slot. So I will test if the card works now, and if not, I will try to find out what resistor needs to go here and put another DRMOS here. And if the card then doesn't work, well, then we will have to go into advanced techniques, and I really hope we don't have to, because I wanted this to be a straightforward repair. Anyway, time to test it, and hopefully it works now. So, my suspicion was right. The card is working now, even though it is still missing one of the vCore phases. But with 7 phases, the card does run, it has installed the drivers, and I can demonstrate that. Oh, I think the card just crashed. Probably didn't like that. Okay, so a little bit panic. The card did shut down on me, but there was no short circuit. The card shut down because of either over temperature protection, because yeah, my cooling kind of sucks, or maybe it detected some error. But like you can see, it runs a little bit. The VRM squeals quite a lot. It is still missing a phase, and it has no cooling on it, even though the temperatures seem fine. But yeah, I will be completely like restoring the VRM now, and I should really turn this off. This is getting very hot, so let's turn that off. But yeah, so this repair is, well, it's not completely repaired yet, but I will call this a success at this point, because the card didn't run when I got it. It had a short circuit on it when I got it. It now runs. It doesn't have a short circuit anymore. It installs the drivers, which is the most important part, so we know that the core and the memory are in fact still functional. And I will be salvaging another dead I will be salvaging a functional FDMF6823C from a dead card that I have. And my hope is that that card, because that card is also a pallet, I hope that that card will have these 2 resistors on it as well, so I can just steal those off of the dead card as well and put those back on, because as far as I know, these resistors next to the DRMOSes are quite important and will probably not work without them, and it would be a shame to have this VRM only function on 7 phases. If I'm lucky, I might get schematics for this, or I will just have to pull one of the resistors from the other card, determine which resistance it is, and then buy a resistor of that resistance. So yeah, I will end the video at this point. So this might be a part 1. There might be a part 2 of where I fully restore the card. Like, I will do overclocking on this. Like, every dead card I buy because I want to overclock it. Buying dead cards is just a way of getting cheaper cards for overclocking, and also because I find it fun to diagnose and repair graphics cards, at least when the failures on them are something like this. This kind of repair I very much enjoy. Repairing traces from ripped memory pads like on the 980 Ti, I do not enjoy. And repairing that BIOS problem on the 960, well, I still have to do that. I haven't started on that yet, but at least one of the cards I have gotten into a functional state. Like, it is a 980. It probably works fine with just 7 phases. Like an 8-phase VRM with 50 amp DRMOSes is quite overkill for a 980. Like the reference PCB, I think that's actually a 4-phase. So, yeah, this is twice the amount of phases as a reference when it's fully functional. So, it will probably work just fine with 7 phases, but you know, I like having the full functional phase count. So I will be completing the repair at some point, but not today. And I kind of want to get this video done, so that's why you're not seeing it yet. But we have gone through the entire diagnosing and going through how to repair the card. So it showed up with missing fuses because those fuses were blown and were removed by the previous person who had the card. The previous person also removed 2 DRMOSes, which I presume they found were dead. There was a third DRMOS that was dead. We pulled that DRMOS. We then prepared some pads. The seller did graciously send 2 FDMF6823Cs with the card, so I just used those, soldered them on, because as it turns out, you need the PCI Express phases to be functional, or at least one of the PCI Express phases to be functional for the card to boot. probably because it's only using those minimal phase counts at boot up. And now we have gotten the card into a state where it does function. There's, as I just said, still stuff that needs to be done, but the card is in a functional state now. And yeah, I will be completing the repair at some point. I might be doing it on video, I might not be doing it on video, I might actually live stream it. I'm not actually sure, but don't be worried, I will finish the repair proper on the card at some point. But anyway, this will be it for this video, so thank you for watching. I hope you learned something. I hope this could maybe help you with diagnosing, repairing your card, because I know that every repair video I make it is used by people to, educate themselves about their broken graphics cards. I am aware of that, which is why I always preach to, replace fuses properly, don't do what I do, because I know what I'm doing. You might think you know what you're doing, but just, this is a card that will only be overclocked. This is not a card I will put in my daily system and run. So there's a difference, and most people will probably repair cards that they plan to actually use, in which case, put those fuses on. Just put those fuses on. Thank me later. Anyway, that's it for the video. I already did the outro, so I'm just gonna say goodbye. Okay, there's one small update concerning the missing resistor on the card. I have looked at some schematics, but actually I got wrong numbers from those because, well, the schematics told me that these resistors are not in parallel with anything because they connect 5 volts to pin 1 and 38 of the DRMOS. And I just measured the resistors on the card, and the lower one, which we still have in the missing phase, is a 10 kilo ohm resistor, and the upper one is actually a 0 ohm resistor, which is very nice because we can just short this resistor out with a little bit of solder or a very small wire, and then it will be as if that missing resistor is there, because that would have been just 0 ohms anyway. So that's quite nice, that's a lucky coincidence. I don't need to do any fancy things for getting that new resistor. I just need to short those 2 pads and then get another FDMF 6823C, which I have this card for because the VRM on this card died, and there's still 6 functional FDMF 6823Cs on that card that I just need to pull and resolder here. So yeah, just a little add-on to the video. Bye!